I'm Dustin Grinnell, and this is Curiously. Ever since I was a kid, I loved reading science-based thrillers and cautionary tales about science and technology. I grew up on a steady diet of books by Michael Crichton, Ray Bradbury, George Orwell, and Aldous Huxley. I'm a huge fan of sci-fi movies too, especially new films like Her, Arrival, and Ex Machina that depict how realistic-seeming science and tech would affect us all. In many popular sci-fi stories, I'm usually both fascinated and horrified by the possibilities of what I'm seeing. It was thrilling to watch scientists harvest ancient dinosaur DNA and use genetic engineering to bring them back to life, but terrifying to see them start using humans as a food source. It was fun to imagine your phone's talking assistant software organizing your life like in the movie Her, until I watched somebody fall in love with it. And who wouldn't want to adopt an alter ego and play out some fantasies in a virtual world? Sounds great until you see a movie like Surrogates, in which most people retreat from the real world and spend most of their time living in virtual spaces. The best sci-fi makes us ask questions. How close are we to realizing these scientific breakthroughs? What are the ethical implications at play? Even if we can create a certain technology, should we? To help us sort through questions like these, I invited Dr. Nisha Iyer onto the show. Dr. Iyer is a biomedical researcher and an assistant professor at Tufts University, who teaches a class to first-year biomedical engineering students, in which she explores the science and technology in 5 popular sci-fi movies: Jurassic Park, Gattaca, Never Let Me Go, Ghost in the Shell, the 1995 version, and Avatar. In her class, Dr. Iyer engages students in discussions about genetic engineering, cloning, artificial organs, space travel, stem cells, and more. How close are we to realizing the scientific advances depicted in the sci-fi movies we love? How might these advances affect our everyday lives? What are the possible unintended consequences? Who would regulate it? What laws may need to exist? Is developing this science or tech even a good idea? We discuss all of these questions and more in today's episode with Dr. Nisha Iyer. Nisha Iyer, welcome to the podcast.
Hi, nice to be here. Thanks for inviting me.
Yeah, so I first heard of you on NPR's Brilliant Boston segment, I think it was. Mm-hmm. And you're a biomedical engineer, and you are teaching first-year engineering students a class that is very interesting and caught the attention of this program. And I listened to it with rapt attention because the subject is the use of science fiction movies to undergraduate engineering students to understand how plausible the science is within those movies, and then some of the ethical implications for that technology. So I was hoping maybe you could just talk about how this began. How does a biomedical engineer such as yourself get to teaching sci-fi movies to undergraduate engineering students?
Yeah, thanks so much for that question, because I get a lot of questions about it. I love talking about this class because I think growing up, everyone watches sci-fi movies. It's probably the way that a lot of scientists and even individuals get a lot of their ideas sparked on science and what is possible and how that science interacts with the lives of people. And it might be dramatized people, but people nonetheless. And so those interactions on the screen, I think, really inform what lay people, students, families, people who are not scientists really think about science and interact with science. So for me, as someone who enjoys watching these films, thinks really deeply when I am watching things on the screen, using that as an entree, as an introduction, an accessible way to start talking about these topics and organizing these scientific topics in a way that is not only accessible, but makes sense and starts to build from, well, this is a really high level way that science can interact in the world and potentially in very dramatic, crazy ways that then give rise to these amazing narratives, these stories that we get to tell. But then how do you break down what might be a really, really small component of these films, just a concept or an idea or a technology, and really think about how possible is it to make that technology? How would we as engineers or as students, how would you go about making that technology in the film? Or is it possible? And if it's not possible, then what are we doing right now that's kind of getting to the things that are possible or that would have very similar roles? And so my class is Sci-Fi Bioengineering. And again, the idea is to really introduce engineering students. And these are students that are coming in with no other backgrounds. They're high school students that come from all over the world. They've never taken engineering class before for the most part. And they're still taking these really basic science, math, very basic kind of sciences to get that foundation. And this class is really to just get them excited about engineering. How do we as engineers think about technology and developing technology, and how do we use what we know to build these things, and then how are these things then interacting with society? So engineering as a subject is an applied science as opposed to basic science, which is just learning more about things. And as engineers, I think our role is to build things for people. And that human science interaction is something that engineers work on. That's in our careers. And that is so much the story of sci-fi films, right? How science interacts with people and how those interactions can do, again, wild, crazy stories.
Yeah. And as a science fiction lover myself, I grew up on, Ray Bradbury and Michael Crichton, and I read books like Jurassic Park, and I read it with great interest because it's about application of imaginative technologies that are usually just like a little bit out of reach. But I think one thing Michael Crichton did especially was a sense of realism in the books and in the movie. It's a sense of like, whoa, we're not that far away potentially to something like this. And it sparks the imagination of engineers who may want to try to practically make that leap.
And I have to say, when I was preparing for this class, I hadn't read the Michael Crichton book. I was very young, and so when it was that big bestseller phenomenon, I was too young to really appreciate it or read about it. And so I read the book, and I was just really astonished how close some of those technologies, those methods actually are to what we do. And when he'd written the book, genetic science wasn't as mature as it is now, in the 2020s, in the early 90s. And so it's really remarkable for me to have to step back and think, this was really forward thinking. The way that companies were going to interact with these genetic technologies, how scientists were going to be working in the lab, analyzing data, doing these kinds of comparisons, creating, novel things. And that was captured in a book so early. And to what extent did scientists who grew up with this book really see this book and then integrate that right into the science that we do? And again, using these stories as inspiration for scientists, and how much that has now fed perhaps into the science that we actually do today.
Yeah, I mean, if you think about Jurassic Park in general, just in terms of sequencing and genetic engineering and leading maybe to CRISPR technology and the mapping of the human genome in general. But even more specifically and kind of like oddly, we think about today, aren't scientists thinking about like resurrecting woolly mammoths? And George Church, I think he's a Harvard geneticist, he's put that out there.
Yeah.
And we're there. We're thinking about resurrecting ancient DNA.
Yeah, absolutely. And these are exactly the topics that we talk about in class. So, you think about a film like Jurassic Park. What are all the science that you need to know or be able to implement in order to do that? And so again, thinking about first-year students, that means learning about the building blocks of life, learning about DNA, RNA, proteins, how those contribute to, the final kind of product that you might have. How would you go about reading DNA, editing DNA, thinking about then, sequencing technologies, CRISPR technologies. How do you implement that in embryos? So how do you genetically engineer organisms? And how are different organisms perhaps difficult to do? It's very different, genetically engineering a single cell compared to something that's alive or something that is an adult. And so that there's different science that goes behind that. What is actually possible to resurrect? How old of DNA can you resurrect? And so dinosaur DNA is kind of getting up to the physical reality. It's too old. DNA is too degraded. We can't actually bring back the dinosaurs. And so students understand, learning that it's not possible to take Amber and kind of the more sci-fi fantasy part of that film. But what is possible is, stuff a little bit newer. So the woolly mammoth, only hundreds of thousands as opposed to tens of millions. And that scale is really important when we think about that genetic material. And even so, it's not the woolly mammoth that's coming back. It's a East Asian elephant that's being edited to have woolly mammoth-like features. So it's not quite the woolly mammoth. The animals that are really being brought back, things like the thylacine, are much more recently extinct, only a couple of, less than 100 years old.
And those are?
Those are the Tasmanian tigers. So that's one of the newest projects, I think, from Colossal, this company. And so, again, thinking about how the age of DNA contributes to kind of that quality of DNA, how that quality of DNA then really controls what you can or cannot do with it. So you can definitely, splice in parts of the DNA or understand what that DNA was and kind of create equivalents in modern animals. Or you can take extinct animals, but the quality has to be within a certain range. And so these are kinds of those quality control metrics. These are the basic science, kind of the practicalities of, what would go behind something like Jurassic Park. And, this can take a long time to even get to the point where we can discuss. A lot of science goes into even just understanding what is or what is not possible and what can scientists do with that. What should we then be doing with that? So things like bringing animals that are recently extinct back into their ecosystems versus doing things like genetically engineering mosquitoes to try to get rid of malaria or other kinds of airborne diseases. And that's inserting genetic material that doesn't belong in nature into these animals potentially and changing our biodiversity, changing what our ecosystems look like. And so what responsibilities do we have when thinking about implementing these in, living creatures that are going to go out into the wild?
Yeah, first of all, bummer, no possibility for a Jurassic Park. It sounds like there's a myth-busting aspect to some of this work.
Yeah, absolutely.
Is that it didn't occur to me that the DNA would degrade to such a degree. But I want to pick up on that idea of it's not could we, should we. It's Michael Crichton's, it's the Jurassic Park. It's the theorist who's saying, your scientists were so preoccupied with whether or not they could, they didn't stop to think if they should, right?
Yeah.
It's a famous line. And I guess the question is, should we be tinkering with genes in mosquitoes, even if it has a profound public good? What are the possible unintended consequences? What are the ethical implications of that? How do you yourself and students work through those questions of even if it's plausible from an engineering or technological perspective, should we? Because we can't anticipate what could happen because we'd be playing God, so to speak.
Yeah. Yeah. And I think this is not just the role of scientists. I think that's really important, right? That there is a public science, there needs to be conversation and interaction between policymakers, the public folk, potentially individuals who live in these environments, consideration for animals, for the plant life, entire ecosystems, and of course scientists who may or may not feel comfortable or able to do these kinds of things. So, in the case of the mosquitoes, there is, right, this huge public good that could be had. You can also think about things that, even without genetic modification that we should and could think about. The role of humans and human-induced climate change on, animals' environments. Is that not also a way that we are affecting, animals in the environment? There are now, recent evidence that there's genetic drift in animals that live in urban versus rural or, non-human occupied areas. So that by just living, we are, in the way that humans live, that we're not actively, but we are certainly changing the trajectories of different species in their evolution, right? By virtue of being near us.
Also, in some cases, putting our own species at risk with infectious diseases where there's less kind of forested area. Yeah. So now.
And invasive species as well. A lot of the public health problems with mosquitoes, ticks. You think about the insects that are decimating tree populations or have agricultural impacts in waterways and in land. All of those are brought and moved by people into places that they don't belong, and they're causing problems. So, outside of just the science, just by being human and living our human lives, we are, making these dramatic changes. So how are any of those different from perhaps putting a genetically modified mosquito in? And I don't know the answer to that. I'm just suggesting, that these are questions that exist beyond kind of the sci-fi genetic modification of animals or anything. These are things that we already do and that people are already discussing without that kind of very poignant immediacy of, this is an intentional plan, as opposed to things that are already happening. And so I think it's important to think about that in a balanced way, right? This is an intentional thing that we could do, maybe put modified mosquitoes in. There is huge public health benefits. Thinking about the cons of doing that, what potential things could go wrong and how do you potentially mitigate harms. But also outside of this context, what are topics and things that we already see in society that very closely mimic what could be happening? And if you care about this, but you don't care about those other things, then what kind of ethical frameworks are you working in? Are you only concerned because it's scientists who are doing it? Or are you concerned about kind of the larger impact that humans have on ecosystems beyond kind of just that single case of, genetic modification?
One thing I love about the movie Jurassic Park, and there's that scene where Malcolm, the chaos theorist, delivers that famous line. But what I love about that scene, too, is that there's multiple representations at the table. So there's two scientists, there's one mathematician, there's the lawyer who's a lay person, and there's the founder, and they all have their own backgrounds. And what I'm getting at is why does it often seem like the ethicist or the philosopher and the scientist aren't always in the same room at the origin of the technology or the scientific advancement. Because that's, I think, what your class is sort of doing, right? It's like, let's think about the science and the ethics and the unintended consequences all at the same time at the inception of the technology. Because I think that's what
I think that's one of the things I'm trying to do with my students, certainly, at the beginning of this career that they're going to have and their decision to become engineers, thinking ahead of time what and how they could be putting science into the world and how we should be thinking about things. And I don't think that that's very often done in science education. I think it's something that happens on the side and with less intentionality, and certainly as a consequence of perhaps bad things happening in the world that we have these conversations, but certainly not on the front end. And so that's definitely something that I enjoy thinking about and enjoy doing. And I think it is really awesome to think that kind of huge big picture right at the beginning, to have that inform the rest of what you're studying and thinking about, how you think about things in the world. But as the science is being incepted, I think it's really hard, as a research scientist, because, I love teaching, I love this class, but I mean, at the end of the day, I also have a lab and I also do research, and I work in stem cell research, which has its own controversies and its own kind of a lot of ethical kind of stuff around stem cell research. And when you're in it and you're doing the research, it's very incremental. And it's really hard, I think, when you're in the weeds to see the forest. And so when you're making these incremental changes, not even one lab or one person, right? It's a whole field. It's this dispersed set of knowledge that is being created slowly every day by individuals in the laboratory. It's really hard to see until there are these pivotal moments that happen, right? Someone has edited an animal. Someone has implemented this
like
in,
the dollies
in people.
or
And it takes these really proof of principle things to hit that public consciousness, where for scientists, this is all just a very logical, incremental change onto the thing that has happened before. But it takes those kind of really big splashes, in the news media needs to pick it up, right? Those big splashes to really hit the public consciousness, and for then there to be that kind of active conversation of what could be happening. Because until the science has been developed, there's not a lot of people that are really interested in policing it. And that's not a bad thing. And that's something we talk about in the lab, in my course as well, At what time should there be this intervention? Should we be slowing research down, speeding it up? Who should be involved in these processes? And to what degree do things like policies that ban stem cell research or policies that ban animal research or CRISPR technology in certain ways, to what degree does that put us at a competitive disadvantage if someone else in the world is going to do it? Outside of the United States, we live in a Western structure. To what degree does that prevent us from developing life-saving technologies? So do we have a moral obligation to use the technologies for good? And is there some kind of problem that you're causing by preventing those technologies from being developed? These are really hard questions. And there's not a single force that is doing that for every single field of science. And so I think these are really great. And it's really amazing to even bring these up to students and just have them think about what is stopping anyone from doing anything. And if there was something stopping scientists from moving forward, is that a bad thing as well? So where are we? And where should we be?
Yeah, and I think that's exactly why science fiction writers do what they do, because it's sort of, here's a simulation for consideration. And in often cases, it's sort of dystopian. It's like, here are the unintended consequences of this invention in this particular application. This is basically like every Black Mirror episode, right?
Absolutely.
And so it's sort of to like wake us up, to scare us, and to say, oh, wait, that's an eventuality if we took this left and that right and this left. So the story sort of gets right in your face and says, we've dramatized this potentiality, and now it's on the table for consideration. And
I love that that creates a safe space to talk about these things. Because when you talk about it to scientists or politicians or, grant funding agencies, the people that are funding the research, it becomes very technical and it, again, loses that human aspect. And at the end of the day, right, science does interact with people. It interacts not only with people, but with ecosystems, with the planet. And without those stories, those narratives, to at least give us a framework to think about those possibilities, we have to wait until it actually happens in the world, right? for someone to really mess up and to create some kind of huge disaster before there's backlash, and that backlash can be harmful. And so I think using science fiction as a way to not only inspire and to learn, but to also be a place where we can discuss where human characters went wrong or where societies perhaps made poor decisions is a phenomenal way for young scientists to talk about these topics in a world that is not based in our own. So you can bring people together from, again, multiple backgrounds, faiths, geographic locales, and have conversations, because this is just a fictional world. We're just talking about, a story. Yeah, it becomes play. But through play, we think really deeply about these philosophical elements of the science that we're doing and the ethics of it, which I think is really cool. And it's not, I think, always what science fiction writers think about, but it's certainly one aspect outside of just the story, right? How decisions, right, can cause both good and bad.
Yeah, I think I heard a science fiction writer say once his whole job was to prevent civilization from destroying itself. And that's a sort of Orwellian approach.
Mm-hmm.
I think even Huxley, who wrote Brave New World, he was asked, what's the point? What are you up to here? He said, don't let it happen. Don't let it happen. Don't let this future society happen where we're like drugging ourselves into bliss and controlled, our minds are controlled through pleasure and things like that.
I know. And then when you think about what cell phones are, every day, TikTok or doom scrolling, are we not doing that? Has technology not always already?
It's a Huxley world.
Have we not already created technologies inadvertently that do these things that, someone thought it was going to be some kind of drug, and it's instead, this glass screen that we have. So, again.
You mean a Black Mirror?
Yeah, exactly.
Sorry.
It's amazing that even unintentionally, the ways that technology can lead to these dystopian realities that people used to write about. And now we just take it's normal. It's been normalized. And is that good for the human experience? Is that bad for the human experience? It's neither here nor there. It can be both good and bad. And that's why ethics are important to talk about and think about. And I think it ends up being an individual decision, right? What is the human experience that individuals should have or should seek to have?
Yeah, imagine you have some pretty stimulating philosophical discussions in your class, which is like, take a cell phone, for example. Obviously, there are many advantages, conveniences to your life. I mean, it's amazing what you can do. You can be in contact with the internet and in contact with your family and friends, etc.
It's the history of the world, of everything is at your fingertips, which is incredible. If you think about, when we were growing up, you would have to find an encyclopedia, and the encyclopedia was the best thing, and you had to get every edition to even just know things. And the internet is just instant knowledge at all times, and that puts a lot of, mental lift off of perhaps remembering things. We can spend more time maybe not reading encyclopedias and more time, actually implementing the knowledge that we've sought. But it also means that it's a source of distraction, and it means that attention spans are lower. And it's not something we talk about in my class, which is more bio-focused, but is certainly a way that technology interacts with people in both unconsidered but also really amazing ways. And it's really hard. It's really hard. I think that's what we decide in my class at the end of the day. We have really great discussions and there's a lot of opinions, but there are no answers. And I think that's also hard for a lot of people to come up with. It's that the world is not black and white. And science, despite being this thing that should be black and white, is not always black and white. The science is real or not real, but how it should be used and implemented in the world is definitely up for debate.
And the pace of technology has been accelerating. And so I feel like more and more every day, every hour, we're having to face these complicated conversations that become exhausting. And
isn't it better to check out? Or isn't it easier to check out?
Check out of the conversation?
Yeah,
and just sort of let the technology happen and run its course, which may be running off the rails or being harmful. But it seems like every sector of technology, there's some sort of new philosophical unintended consequence to grapple with. I think, there are no answers, is what you said. It's mostly about the questions. Should we, can we, how would we, could we modify this so it's more safe? Could we do it this way instead of that way? It's more like the questions. Yeah,
and I think science fiction, as you mentioned, is dystopian. Mostly in nature, it tends to be very extreme, potential unintended consequence of, whatever ethical quandary the world might be facing. So another film I do is Gattaca. And very often when 23andMe, that genetic sequencing company, became public, that was the first thing everyone thought about. Oh, Gattaca, right? Gattaca, this film about, when everyone knows what everyone's genetic code is and what your gene means for you as a person, that it's going to control a whole society and everyone's going to start being judged by that. But, to what degree are we already judged by things like our socioeconomic status or the color of our skin? This morning, Supreme Court struck down affirmative action, and to what degree could that have been encoded in the genome? And yet, with 23andMe technology, it hasn't, dictated our society. There's still privacy laws, around the sharing of genetic information, and there's also a lot more information that we know about genetics, right? That all of who you are is not written into your DNA. That there's the epigenome, which a lot of students don't know about when they come to my class, right? Which is the way that DNA is modified as soon as you're born, or even before that, to, change how different proteins and therefore cells and therefore the phenotype or the outcome of who you are changes as a result of your life experience. So it's not just the genome, but also that nature and that environment and that nurture and not only your experience, but the experience of your family, right? Your mother, your father, and how that information gets translated onto that egg and sperm. So we are more than just our DNA. And so with the way that we know about science right now, we'll never have a world like Gattaca because there's no way to become born and be able to read that, to know what you're going to be on the other side. That's not how genetics works.
We couldn't read the epigenome, potentially? Or?
I mean, we can, but it's constantly changing. And so how can we start modifying the epigenome? The way that we're trying to modify the genome with CRISPR technology is something that people are definitely looking at. How can you do things like potentially rapidly age or de-age cells? How can you activate regenerative pathways? These are things that are, all new science that is still happening in the laboratory. And as, people are understanding about the basic science, trying to come up with strategies to implement that in people, and, what does that look like? And we'll have perhaps another kind of huge wave of drugs and therapies, hopefully, that goes after the epigenome and can help us live healthier, better lives.
It's interesting because the first two movies that we've talked about, 2 of 5, I think the others that you teach are Never Let Me Go, Ghost in the Shell, not the Scarlett Johansson one, but the earlier one in Avatar.
The better one,
right.
the anime.
Right. It's interesting because Jurassic Park and Gattaca, you've said of them both, we're probably not going to have those worlds, which is great. Right? Because the world in Gattaca, which is one of my favorite movies, by the way, it's a story of genetic determinism. Like you said, you're sort of defined by your package of genes, where you go in the world. And it's great that we probably won't have a society like that because it's completely...
It's not a good society.
It's an immoral society that creates like caste systems and your have or have not based on...
And yet that is a movie of optimism, right? The protagonist is a person who, despite their subpar genome, this congenital disease, goes on to do a really remarkable thing and is the best in the company. And, goes to show that we are not all in our DNA and that you can do things even in this really judgmental, reclusive society based on technology that transcends that technology. The human capacity is more than what might be written by nature or otherwise. And I think that's a remarkable thing to think about. In a lot of aspects, we think a lot about the negative parts of technologies, but how many more people in the world are educated because of cell phones? How many more opportunities do people have because of the internet, no matter what kind of negatives, right? That technologies, as they're developed, should be improving the human condition. I think that it comes out to being human, right? That humans have so much creative capacity and the capacity to do so much despite or because of the technologies that they interact with.
Yeah, that's what's remarkable about Gattaca is that it is a dystopian world, but you have a protagonist, Ethan Hawke, who is so willful and he has like a heart of a lion and he will not stop unless he becomes an astronaut, which is his dream, which is statistically 0% chance he has based on where he started genetically and in life. And so it really is a message of the human imagination and human will can win out despite how wrong we've gone as a society in that world. And that's a mission of goodness, which is a little bit unusual in the world of science fiction that tends to go dark on most of the scientific advancements.
But there's even a huge number of people that are helping him in that film do this, right? There's the donor of the genetic material, Uma Thurman, who's his girlfriend. There's the doctor that does all of his screening for all of the testing that he needs to do as part of the space company. And there's so many people around him that are genetically perfect or who have been placed in positions of privilege in this society who are also trying to lift up someone and protect someone who has been hurt by this society and who has the capacity to grow and do these great things. I think that also speaks to even the privileged in society and people who benefit from technologies or otherwise can see what the problems are and can move beyond it to try to make a better world, right? And try to give opportunity where it belongs.
Yeah, and this was most powerfully displayed at the very end of the movie, right? Right before Ethan Hawke is about to realize his dream of going on a space shuttle. Spoiler, I guess. And the doctor who's been testing him throughout the story and, making sure he is who he says he is, he does a surprise urine sample right before he goes on the shuttle. And this is game over for him because he didn't expect it. Ethan Hawke had all his ducks in a row. He'd figured out every way to deceive the system, but he got caught right at the end. And the doctor just let him walk. And that was a really nice moment because exactly to your point, even in an amoral society, there are people who recognize how wrong it is. And this is their little rebellion,
Yeah.
And that's what will happen in that society. It may not be outright revolution, although that's probably what it's going to happen eventually. It's these little rebellions against wrongness.
Yeah. Yeah, and I think that's just so much fodder for the imagination to be able to think and predict where these characters are going to go in that film. I think that's what makes it such a great film is you don't know if he gets caught. You don't know what he does when he comes back. They kind of set up these individuals and their stories and set up these little rebellions. And you can just imagine what will happen on the other side. And hopefully it's a society that's better and fuller. That's, I think, the only thing we can hope for is that hope element. I think another nice thing about that film, that I talk about is it was, again, like Jurassic Park, thought about in the early 90s during the Human Genome Project. And there was a lot of fear, I think, at that time is, if we can know and access the human genome, then there could be all of these things that happen. We could bring dinosaurs back if we knew what the DNA was. We can predict one's life and we would have this society that was kind of unequal based on the perfect DNA that different people have. And the Human Genome Project took 13 years in the 90s to sequence the first human genome. And it's just remarkable that there are a lot of technologies that were developed much sooner than our ability to actually edit the genome and implement the stuff in Jurassic Park, like cell phones, for example. Keep getting back to the cell phones that weren't in that movie. That the idea that you could just walk onto a spaceship in a suit would be enough, that, their idea of training was just doing a heart rate thing. So I think it's a little funny to see these anachronisms, especially in these films now living in the 2020s, that we have so much technology that has made things like communication and computer technology so great, and they envisioned all of these biological technologies being so much more advanced than where we are on the computer side. And then the bio is really much harder to implement than technological advances that you see in say, computer science or electrical engineering or other kinds of engineering disciplines. And that's because we just don't know very much about biology. That just knowing about it doesn't mean that we can engineer it or implement it in ways that actually will have an impact on people, and that the time scale of biological discovery is just much longer. You can throw billions of dollars into biology research and get nothing. You look at the race for cancer cure. We know a lot about cancer, and we still can't cure all cancer. And that's just because biology is really hard. And I think, again, from an educational standpoint, I think it's really important for students to understand that you need to know the biology to do kind of bioengineering, biomedical engineering, but we still need to know a lot about the biology. And then even when we know about it, it's really hard to get that engineering aspect down. It's a huge challenge, and that's what makes it so cool and interesting to work on, because this is a huge potential field. There's so many opportunities if we can just get that stuff right.
Yeah, it's so cool and interesting, but also probably maddening from a scientific perspective. I studied physiology in grad school, and I was just struck by how the systems work together in such a complex way. And especially just when you go into the cell and you think about intracellular signaling and all that. And it's just this dizzyingly complex arrangement of systems.
And so, as a stem cell scientist, I am constantly amazed by this great technology that's coming out. Just in the last couple of days, we have FDA approval for islet cells. So these are the cells that create insulin that are damaged when someone has diabetes. So we have stem cell-derived human cells that are potentially going into patients to cure people of diabetes. So you can get this stem cell transplant and it'll create insulin for the patients so they don't have to take insulin. For Parkinson's patients, so these are patients who have this degenerative disease of the dopaminergic neurons in their brain. So it can cause tremor, eventually paralysis and death. So really terrible neurological disease. Stem cell transplants also happening for these cells. So can you replace those cells that have degenerated in the patients and therefore get that function back? And so these are huge advancements that, hopefully they're in the clinic and they're going to be available to patients. But it took 20 years from when stem cells were first discovered and imagined to be as part of kind of these regenerative therapies to the point where we're still in clinical trials. We're still just determining if they work, but that's a long developmental timescale. And a lot of people have gotten really bored about stem cell research in the meanwhile. So it's just remarkable to see these technologies finally making it in the 2020s. These things that these films talked about and maybe imagined early on and are just now happening. So not organ replacement like in Never Let Me Go per se, but definitely individual cell types and thinking about how you can use biology in the dish to regenerate and cure different kinds of human diseases.
Yeah, I always think about the line in Jurassic Park, the movie. It's nature always finds a way, right? What a wise saying. It's, especially in biological systems, there's so much evasion and adaptation and like unanticipated tricks. I can imagine maybe we put the islet cells in people's pancreases and something happens that makes the whole theory crash down or something, unfortunately. We could discover that in clinical trials.
And if I could probably run a whole class on this, right? Like the science behind just how do we know those cells are what we say they are? How do we make sure that they function? How do you protect them from the immune environment? What kind of transplantation strategy we'll use? So what is going to be the source of your cells? How are you going to make them? Then actually making them in that process, years worth of doing it. If you finally have a technology and maybe a drug delivery system, right, some way to protect the cells from being degraded, well, then what are all of the regulatory hurdles that you need to pose? And so these are things we talking about in my class, the patenting process, what FDA approval looks like. How do you run clinical trials? How do you do the statistics for clinical trials, right? How much money needs to go into all of this? Where is that money coming from? Is it coming from companies, governments, individuals? Who is doing the research? And after all of that is done, you need to create something that's cost effective, which means you need to go to business school too. So this isn't something that you can just imagine. There's this whole infrastructure around perhaps what is a single disease-bearing therapy. And this is happening in parallel for thousands of diseases in the world. And they're at various stages, and I think the scale of that, again, thinking about those first-year engineering students is quite remarkable when you're still taking that basic biology class. And maybe if you want to take something to clinical trial or you want to cure someone in the long run by being a biomedical engineer, this is all of the stuff you need to think about. This huge process, this huge scientific enterprise that you're entering, which I think is pretty cool.
Yeah, totally. So I'd love to talk about Never Let Me Go.
Yeah.
So this is a movie where essentially children are raised to be identical clones to older people who would like to later harvest these donor clones for their organs when they get older. So maybe you are 75 years old and you need a new kidney, you go to your donor, you go to your clone, and because they're genetically identical to you, you can take their kidney and put it back in you as a replacement. So people are being bred essentially for replacement organs. It's a pretty bleak movie. It's pretty grim, and there's no Gattaca hope to it. But where the movie The Island has also explored that area, where are we there? Because that to me seems, I could see some biotech entrepreneur doing that right now. Like,
Yeah.
you know,
Yeah, and so that's the crazy thing I think we talk a little bit about in my class is if we wanted to clone humans, I think we could because we have active DNA. We know how to modify the germ cells, so these eggs and sperm. Like we can do in vitro fertilization, and we can think about doing something like that with people that are alive today. I mean, there are a lot of technologies that are just being developed to create kind of artificial embryos, artificial blastocysts. These are not quite the same as the ones that happen naturally, but they are starting to happen in the dish. It's just happening just in the last few years. There's a lot of controversy around it. A lot of people are really concerned about where this technology can go, but at least right now, there are the glimmerings that it could happen, that we could create, with your cells, say, literally thousands of clone embryos in the dish, using very commonly used technologies. That technology isn't mature, but it is happening. So can you create a lot of clones of humans? Potentially, even though it's still just in development. Can you edit those embryos? That's much harder, right? That gets into the realm of kind of Gattaca crossover. But can you do the clone to begin with? Sure. Genetic modification, harder. Cloning, more easily. The problem is aging right now that I see it, that you need to be able to grow these organs to a size and an age that is going to be useful to you. And so that is where all of kind of stem cell research runs up against a problem where we can create really early versions of cell types and organs. We can even do things like take an organ from a pig or another person. We can take out all of the cells and then try to replace it with cells from you to try to create something that looks like your cells. But the problem seems to be that the stem cells remain really young. It's really hard to create organs that have that same kind of functional maturity that you do have as an adult. And that is a big roadblock in stem cell research right now. How do we think about going beyond kind of these very early developing tissues and create environments and tissue structures that are much more like you would have in a person? So there's a couple of routes that, people are looking at. One is the engineering route. Can we create materials and stem cells and combine them in ways that kind of improve the maturity of these tissues? So you don't need to do things like create an organ. You could just create it, say, in a big tank or something. That would be great. And so that's, what tissue engineers like me try to work on in different ways. Another kind of route as well, can we think about maybe not using people, but think about genetically modifying animals to be able to grow these kinds of tissues for us? And so that's another company that are working on creating genetically modified pigs so that you could grow human pig kind of chimeras to grow human heart cells within, like human hearts effectively within kind of these chimeric pigs. And you would be able to then grow the pigs, which grow at a much faster time scale than humans do and get maturity and get to size bigger. And you could then take the pig and take out the heart and be able to transplant into that patient. So that first pig human heart transplant was done just last year in a human patient. It was an N of 1 as a very preliminary trial, and he lived for a number of days before passing away. He had very, very severe heart failure, but it was the first instance of kind of using a genetically modified animal to host these human organs and then being able to transplant that human organ into a patient. And so when thinking about kind of animal to human transplantation, there are a lot of barriers. So not only the human cell type and the immune response, but things like, well, certain animals are receptive to different kind of viruses. So the coronavirus is, a big example. A lot of people, I think, learned about bats and viruses and how viral crossover happens. So pigs also are susceptible to certain types of viruses. And so the genetic modifications that they've had to do in these pigs have to do a lot with making the immune system of the pig to look more like the human immune system, and also to try to reduce the potential for these kinds of organs to get these kinds of viruses that pigs very often get, to prevent that kind of human-animal crossover. And so it's a huge number of genetic modifications they've had to do in these animals in order to make that happen. But this patient didn't have any kinds of problems with either immune rejection or any of these viral things. So he died because he was very sick and the heart eventually didn't take, it didn't work. But the reasons that they had genetically modified this heart, those all worked, that the modifications worked, that the tissue might have worked. And as this technology matures, perhaps this will be huge for organ transplantation. There are thousands, millions of people that die because of heart failure every year in the world, and there's just not enough hearts to go around. And so if we can think about using animals to host these tissues to be able to transplant them, that can save so many lives beyond what we currently have available.
Yeah, the upside is profound. The thing about the movie, like Never Let Me Go, is all of the, if I can call them kind of workarounds from just creating an identical clone that you spoke of, sort of preempting all the immunological responses, the viral responses. You're trying to sort of do as best you can to be representative of a human. But that movie just decided, let's raise humans, because that's probably the most ideal place for a tissue or an organ, right? Because one of the things I was talking about with a friend, which I think is really interesting, is like, why educate those clones? Because like maybe a kidney is healthier if they're educated, if they're in a happy setting, in an environment, maybe if they fall in love, maybe if they have healthy social networks, maybe it's a healthier kidney. So that movie sort of sets a world up where the best donor is a donor who's living a full human life, which is really interesting.
And this is a conversation that we had with my students who are really interested about the nature of animal studies, donor transplant, the potential use of animals or, people, thinking about the ethical implications of growing animals for human tissue transplantation, same way human for human tissue transplantation. Again, thinking about these parallels. Well, we already use a lot of animals for agriculture. A lot of animals are already consumed every year. So, really what difference is it to use an animal instead of for meat or for food, but instead to use them for organ transplant? And that was an ethical kind of dilemma a lot of students had, who thought, we definitely shouldn't be making these clones for human health, but I don't have any problem eating them. That's, again, kind of one of those moral gray areas that people were running up against. And I think very similarly, they looked at these, we kind of did a paper on thinking about organ transplant in animals, and then look at the parallel of effectively treating these children, putting them onto the farm quite literally in this film, where they're growing up in kind of these very rural areas where they're not around a lot of non-clones, that they're living full lives, but they are like living separately. And the similarities between how we treat our animals in agriculture today, perhaps to how, you're treating the clones for those films. The idea that, grass-fed meat is better, or animals that are living better lives are going to be better, not only for the animals, but as an agricultural product, is not totally out there. And is disturbing to think about when you're making those comparisons. And it can be hard, I think, for students to make those connections. But I think it also helps to create ethical clarity in where people's boundaries are, and maybe, what should and shouldn't be legal or allowed or stopped in the name of progress. I think there's just a lot of really interesting conversation that can be had around all of this. And a controversial movie that is very dark, very non-hopeful, can lead to really interesting discussions in kind of these other realms.
I imagine one of the discussions you probably have are those really big kind of philosophical questions, like what makes a good life and why live to 100, So we have these maybe wealthy, privileged people who are creating clones so that they can overcome diseases and live for a very long period of time. What age is enough? If you can get to 100, well, why not get to 125? And but why? Why live that long? Should we?
Yeah, and I think most of biomedical history has been, let's live longer. And that's what almost all of medical science has tried to achieve until now, because we're living the longest that we've ever lived, in this moment. And there are problems with that. We have folk who are getting really old, who are starting to have neurological diseases that we've never encountered. A lot more people are having cancer because they're living much longer, and there's more opportunity for these things to come up. It's created economic, financial, environmental issues with, the longevity that people have, and disparities in different parts of the world as different places are catching up. And so I think it's really interesting to see students understand when I ask them this question, is this something that we need to do? The goal of the society is to continue to prolong human life. Is it worth creating clones, potentially humans, and using them for their organs? And the answer is overwhelmingly, I don't know why anyone would do that. Like, why we shouldn't be extending human life. We should be expanding human healthfulness, expanding health span as opposed to lifespan. But that's a very new idea, I think, for medicine, that's what we should be focusing on, not longevity, but the quality of the health of the life that we are living. And I think that's a remarkable shift, not only in the attitudes of students in the classroom, but, society. I think as society, we're looking for, we live a long time and there seems to be a problem with age. Let's hold off on trying to live even longer than we already do to make sure that the lives that we are living are the best ones that we can. And I think students understand that, and I think that's great.
Yeah, but I often feel like that's great. I do sense the public conversation is more about extending a healthy life than extending the years, and that is great. But I often feel like in human, history, it's like 99.4% of us can sort of get that and strive toward that. But then there's like the last fraction of the population that just is going to push the science forward. And I feel like there are researchers who look at aging as a disease and they don't want to die. And there's some tech entrepreneurs who are heavily invested in living to 500 years. And there's different strategies. It's like reducing damage to DNA and other organs. And a lot of people, I think it was like Aubrey de Grey, I think. I read his book when I was in my 20s, and he's like a crazy man. Like, people think he's completely out there. He's long beard. He has a really interesting TED Talk, and he's trying to prevent death.
Yeah, and there are people who are kind of biohackers, right? Folk who are trying to implement CRISPR engineering in their homes and creating these kinds of homemade recipes. I mean, there's always going to be a fringe population that is interested in doing things that I think society finds to be repugnant or problematic. These can be case by case. They could also be research programs. So a lot of people are still interested in longevity, continuing to reduce the effects of aging. And I think it's important to differentiate between understanding and doing kind of these proof of principle things in a way that is controlled and scientific. And by scientific, I mean, do you have a hypothesis? Are you doing things in a way that is consistent and rigorous in the kinds of experiments that you're running and the kinds of investigations that you're doing? And are you reporting that science that you're doing in a format and in a way that is accessible to other scientists so that you can get review and you can get feedback on that? And that's how we grow human knowledge. And I think expanding human knowledge in a lot of ways, and in ways that don't always make sense, again, kind of thinking about basic science, is great because you never know when you're going to need that information. And I think, the coronavirus pandemic was such a great example of that, where this mRNA vaccine was something that was developed, technology that was developed, and it's found its time. The same thing with coronaviruses. There's very few people in the world that actually study coronaviruses, and they ended up being overnight phenomenons, and it was until very recently just the smallest thing that very few people in the world did and ended up being huge. And it took that investment from public resources and companies into these just basic science. We never know what's going to hit in order for that information to be there for when we needed it. So it's not a bad thing that there are always going to be people that have different goals than the rest of society. And as long as they're supported and doing things as ethically as they can in the most rigorous fashion, you never know when that knowledge is going to be helpful. The problem is when you start to hurt others, you start to hurt yourself.
Right. And also reject scrutiny.
Yeah.
Because I think we should all be under
Absolutely.
Like whether it's from lawmakers or journalists or whoever, we should all be implementing checks and balances on things that can potentially affect us all.
Yeah. And in my classroom, we talk about that. As a research scientist, who am I beholden to? Well, we have a lot of ethics committees for working with stem cells, for working with animals, for working in laboratory spaces, environmental health and safety, biosafety. We have to write a lot of safety protocols, and we have to educate our students before they can enter the laboratory. And then, once the science is done, well, we have the peer review process. And how does that work? And the publication process. Things like, how do you get funding to even do the science? And what kind of review process is done for the funding? And what kind of accountability do we have as scientists, the people who pay and read and review our research? And these are all processes, and a lot of people are involved in just the decision to start an experiment. A lot of people have had input on your ability to do that before any science actually happens in the kind of academic setting that we have in university laboratories today. And that's all really new information for a lot of students. You can't just buy a lot of the reagents necessary to biohack yourself. A lot of them are just simply not accessible to people who haven't gone through some of these regulatory processes.
Yeah, I love how, as you're an academic scientist, you just sort of outline the kind of hoops you have to jump through, the necessary hoops.
To do the first experiment, to do any kind of science, we have to have all of this safety stuff in place. We have to have all of this ethics training and the safety training, and we need approval to even do the science. And so it's not as simple as, I'm going to become a backyard biohacker. It's much harder than that. And I think it's really comforting to know that there are these checks and balances in the way that research is done today.
Yeah, it must kind of rub you the wrong way when you do see a backyard biohacker where they're just kind of injecting things in themselves, and they've leapt over all of the hurdles that are there for a reason, and they can either hurt themselves or worse.
Yeah, and that hurts them the most. They're putting disinformation out into the world and pseudoscience, which is a problem for everyone. It's a problem for us as a society. But at the end of the day, they're hurting themselves, and people hurt themselves in all kinds of ways. So how is this any different? Again, kind of thinking about, people are always going to find ways to try to destroy themselves. And if this is their way of doing that, we live in a country, for good or bad, where they have the freedom to do that. I am even more rubbed the wrong way when people are in places of responsibility and have gone through hurt and these hoops and lie about their work or do things that haven't been approved. And these kinds of scientific mavericks are very, very rare, but it does happen. And that is kind of a community response, right? Are your colleagues, are the scientists working in your lab, are your funding agencies really making sure that you're doing the work that you have? And so that's an accountability thing. It's, again, very rare, but it happened recently with, some CRISPR editing in China a few years ago. Caused a lot of global backlash for good reason, and I'm glad that it got so much backlash, but it still happened. And these things can still happen unless we make sure that we are creating scientific environments and communities where not only ethics training, but that circle of integrity is being maintained.
Yeah, and I feel like, you put the burden of responsibility on yourself for having a well-informed public from a science perspective. Because, we could name so many examples where there's a just misunderstanding with the technology or the science, like stem cells, and we all sort of freak out. But it's all based on misconceptions or a lack of fundamental understanding.
And it's hard to understand.
Because exactly right. You have a PhD and it's still kind of...
Yeah, because understanding what's possible involves a lot of stuff. And I think I try to get my students to understand it's really hard to understand, but these are the places you can look for information. This is how you should evaluate information. And this is background knowledge that you need to have to at least start to understand where technologies that are successful, the kinds of things that they've had to do to get to that point, so that you can feel trust in the scientific enterprise, or you can be a critical thinker, a critical scientist of the world, a citizen of the world, and be able to at least evaluate where the sources are coming from and the kinds of perspectives and opinions they're going to have based on their role in the scientific or public enterprise. And I think an informed citizenry is really important. You shouldn't need a science education to know that you should be able to trust a different source. That's kind of a part of a bigger kind of conversations about civil society and our ability to critically assess information, of which scientific information is only a small subset of the deluge of information that people encounter every day.
One thing I really love bringing it back to the movies a little bit is the sense of realism and the accuracy that's being achieved lately, especially with
so good.
Science fiction movies. Mm-hmm. There's you had brought this to my attention. There's this group called the Science Entertainment Exchange, right? And it's really this group that helps filmmakers get access to scientists from all different fields so that they can enhance the accuracy of the science they're trying to portray in film. And a really good example is the movie Interstellar, where the filmmakers, I think Christopher Nolan, the director and writer, he met with Kip Thorne, a physicist, and they helped try to figure out what would a supermassive black hole actually look like.
Yeah.
And we saw it on screen, right? And to my knowledge, I guess that's like what a massive black hole would actually look like, what the gravity would do to the light and color. I think that's great, It's because why not just get it right?
Yeah.
And we are getting it right in a lot of cases.
And I think that's what makes, sci-fi movies and TV shows and, the things that are showing up on the visual screen these days as a result of these conversations, such great educational material. Because these conversations have been had and they seem realistic because they're probably based in some kind of reality. And that's in comparison to some of the fantasy-like thinking that we had when those conversations weren't necessarily happening. And it's certainly nice to see science that you resonate with or get excited about portrayed on screen. I can definitely say that as a result of doing this class, whenever I talk to about it, oh, do you do this movie? Oh, do you do this movie? And I think it's because we try to see ourselves in the media that, we see on the screen. And it's always really exciting to be able to point to that film. It's like, that's the science that I do. And you can see it right there. And it's not always accurate, but it's the only way that we as scientists often have that ability to talk to people and give them a little small picture of what we do every day for decades sometimes. And it'll show up for like 2 minutes on a movie. And that's the thing that'll stick with you, right? Not whatever academic papers I put out or conversations that I have or talks that I give. But that 1 minute on screen is the work of so many people. That can be really exciting to see.
I'm sure, even if it's only 2 minutes.
Yeah, or less.
Right.
Yeah.
In your class, I'm sure there are common themes and patterns that could pop out. I mean, I think with Jurassic Park, we're talking about hubris, right? Mm-hmm. And hubris is a big one in sci-fi, right? We just kind of fly too close to the sun kind of thing. What else comes out like most commonly in conversations when you're exploring sci-fi?
Yeah, I think one of the things that, I arranged the movie to do is to kind of build up to this idea of, what does it mean to be human in a technologically advanced world. And I think, the next movie I do in the sequence is Ghost in the Shell, where you really have these cyber-enhanced humans interacting with AI that is come to life and is kind of a terrorist in the society, and thinking about how can you tell what is human when we are so integrated with technology, whether that be through prostheses, artificial organs, artificial bodies, brain implants or brain-computer interface kinds of structures that help to connect the biology of the brain to the technologies that we live in the world. And when you start to see, in parallel from the computer science side, technologies that start to look and sound human and perhaps think like a human, then what is the boundary of what is a human versus not? And how should we then be treating our technologies and people and the intersection thereof when the lines are really getting blurred? And I think that's something we build up, right? If we start with the genetic engineering side, and well, that's not nature, it's not natural, but it is something, but it's still based in biology, to the spectrum of, well, now we have a lot of technology that's starting to interface with biology, and independent of biology starting to look a lot like biology. What is human? And how do we treat ourselves and our societies?
So, yeah, in that movie, you have cyber-enhanced humans. You have a character who's really just their brain is left over from death, and it's put into a kind of an android so that it's a super soldier. You have other tech, like people are communicating with other people via telepathy. One character gets hurt, and he loses his eyes, and so he has new sort of robotic eyes put in where he can see way better and see in the night, see in the dark, and all that. So anybody who gets hurt gets enhanced, right? You lose an arm, you get a new arm, a robotic arm. There's also hacking into people's brains so they can steal information. They're also putting false memories in your brain, which is really interesting. So yeah, I guess the question comes back, what is human? If you have lost your biological eyes and you have new robotic eyes, are you a human being anymore? You're definitely an enhanced human. But I think we're all kind of wondering what to call that.
Yeah, and I think it's really amazing because you can point to, oh, you lost your heart. Okay, artificial heart, that's not human. You're still human. Eyes. Okay, so these individual organs don't make us human, but certainly that idea of the nervous system, right? The brain, the kind of epicenter of, what people think.
Your identity.
Starts to get at, oh, well, now you've kind of gone beyond just an individual organ. And that's kind of a place that I also try to push back with students. So an example of this is, well, there are a lot of things that are increasingly thought to influence the way that the brain works, things like the gut. So, you are what you eat. To what extent does your diet, your microbiome influence the way that your brain works, and how much does that make you who you are? So, the fact that we have bodies that have kind of this information that goes from all over the body to the brain and then back means that there's this feedback network that can the brain be the brain? Can you be yourself without your body as it exists? And that's a lot of biology that has nothing to do with neuroscience, but it's the way that neuroscience interacts with the body. That's all new knowledge. Like we don't know about a lot of that, which is really fascinating. The idea of hacking memory is something that people are trying to do with engineering individual neurons in the brain and trying to code and re-access them using brain-computer interface. Brain-computer interface has allowed people to walk again. So thinking about creating prostheses that access the brain and the spinal cord to help paralyzed patients take steps after not being able to walk is technology that just came out in this past year. These are all things that are, happening in laboratories, happening in a lot of tissue engineering labs, a lot of different technologies for not only artificial organs, but in neuroscience, thinking about regenerating the brain, enhancing the brain. And so the future envisioned by something like Ghost in the Shell, especially in the advent of ChatGPT and all of this AI kind of language modeling that we're seeing, is becoming, again, kind of more gray perhaps than it ever has been in the past. And I'm not a computer scientist, and I'm not sure to what degree programs and computer systems like ChatGPT are true AI in the sense of self or being or thought. They certainly sound like humans. They're certainly able to talk, communicate the way, in patterns the way that we do. And if that's the only thing that makes us human compared to say, animals, that ability to communicate, that's maybe a line or a boundary that some people start to get worried about.
Yeah, we're going to have to work some things out as we start interfacing with technology more.
And trusting it. I think things that sound like us, we're more likely to believe and trust, and to what degree that contributes to disinformation and other kinds of scary things that we already have as human society is something to think about.
Right. But that'll be a tumultuous journey. I think a movie like I, Robot is interesting too, because you have Will Smith, this character who has a lot of prejudices against robots, and he hates robots. He thinks he's sort of old-fashioned, and he's skeptical of them. He's skeptical of their intentions.
Even The Mandalorian has a huge subset of that. I think being skeptical of human-robot interactions is also an AI, right? The Steven Spielberg film.
This is happening in all my meetings as well. Like I have, with my team, I have this AI that I invite on that listens to the conversation, transcribes it, and then pops out, a transcript that I can watch. And we joke around about it, that I don't even have to be there anymore. And who is this thing listening to us? And it has become a stuff of jokes, but it is enhancement in a way because it's my tool.
Yeah, there was a great article just the other day about how these kinds of technologies are being used in medical settings to help patients remember what was just being said in the doctor's office, which, most patients apparently don't remember 80% of what was discussed with their doctor right after that conversation. So not only having a record of that meeting, but helping doctors to spend less time on the administrative stuff so that they have that opportunity to be human with their patients. To be doctors. Yeah. And so that is not an enhancement of, perhaps it is an enhancement of the doctors, where we expected them to spend hundreds of hours doing paperwork and very few interfacing with patients, that this technology has enabled them to live fuller lives and be more present as people.
Definitely. I mean, it's certainly, I get time back.
Yeah.
And things are made more convenient.
How much has that made you more able to be human, and to enjoy the human experience?
Yeah, I can certainly go for like an afternoon walk earlier, which is nice.
Yeah.
So as we kind of like wrap up, I wanted to talk about, I remember you saying somewhere that you feel like we're kind of living in a sci-fi film today in a way, given the current pace of change. And what areas of science do you feel like are most sci-fi right now?
Yeah, I think we already discussed a couple of the ones that I'm excited as a stem cell researcher interested in neuroscience. So using stem cells to think about how we regenerate the nervous system and the spinal cord in particular. I am so excited about these stem cell technologies finally making to patients, these artificial organs that are being developed, and whether animals or in the dish, and are finally being able to cure people with biological drugs using cells and tissues instead of relying on medicines that have been recycled or reused or really, really hard to control. They just don't have the complexity, right, that some of this biology has the capacity to do. So that's what I feel really excited about in the science that is happening today and is making it to clinical trials. Things like being able to use CRISPR engineering to genetically modify cancer cells to be CAR T cells, right, to be a really powerful cancer therapy. The idea that you can hopefully edit the cells of patients with sickle cell disease so that, millions of people with sickle cell don't have to suffer their whole lives. These are really, really great strides that bioengineers have made in the last 20 years in the advent of gene editing and stem cell research. That is just the stuff of sci-fi films. And it's only going to get better. All of the stuff that we're seeing right now is just first generation. So we can only imagine what this will look like in 50, 100 years. They'll be looking, at the 2020s and the 1990s as being so old school. And when they look at, the films and the books that we thought were these out-of-the-world things, they'll think it was fantasy. And they'll probably have other things to write about, other kinds of technologies that are going to be more on the mind than kind of routine gene editing, perhaps. Who knows? It's nice to think about what this era of science will look like, 100 years from now, when we couldn't even imagine this era of science even 20 years ago.
Totally. My last question is, you are in your class using science fiction to understand technology and the ethical implications. What do you say to science fiction writers and filmmakers? What kind of movies do you want to see as a scientist and as someone who clearly thinks very deeply about science fiction? What kind of stories and how are the stories told? What would you hope for?
I think the beauty of science fiction is not necessarily technology, right? It's how humans interact with that technology. And there are so many human stories. And at the end of the day, right, science fiction are just human stories. And so having conversations with scientists about what they're excited about in the laboratory, reading, going to conferences, just having those interactions, things like that, science fiction forum for filmmakers, I think are really remarkable because they start to open up conversations between, folk who are spending a lot of time in the laboratory who are really, really excited and have a lot of knowledge about their specific subdiscipline, what they're excited about. And I think science fiction authors have this remarkable ability to take a step back from, again, being in the weeds and look at the forest and perhaps, look at continents and worlds and think about what all of these, real things that we're doing and what they could become. And we feel inspired by science fiction. I hope science fiction becomes inspired by us, but that can't happen unless those conversations happen.
Yeah, and maybe more hopeful stories as well. I think more Gattacas would be. Yeah,
and we're living in a great hopeful time. And the hope should make stories that are enriching and uplifting. And hopefully we see more of those hit film instead of, a lot of the depressing stuff that we end up seeing, unfortunately. Or fortunately, because as you said, I think it teaches us about hubris and ways that things can go wrong.
A little bit of both.
A little bit of both.
Well, where can people go to find out more about your work if they want to?
Yeah, so I have just recently moved to Tufts, and so I'm just starting my laboratory there. So information about me and some of the stuff we do in my lab can be found on our Tufts faculty pages. And hopefully you see more work coming out in my lab on how we can use stem cells to regenerate the spinal cord, as we continue doing this great work. And I hope to be working more on this class and thinking more about how we can use science fiction and integrate that into our educational model for getting people excited about research and about the science that we do as bioengineers, but also to think about these bigger picture things, ethics, society, and what our role as scientists are in the world.
Great. Well, we will leave it there. Thank you so much for coming on the podcast.
Yeah, thanks so much, Dustin. It was really great to be here.
Thanks for listening to this episode of Curiously. I hope you enjoyed this conversation with Dr. Nisha Iyer. Stay tuned for more conversations with people I meet along the way.